let's start by considering this situation. We have a function that describes the cost of a meal determined by the number of sandwiches you buy. So cost is determined by the number of sandwiches. So we would plug in a number of sandwiches that we have, and that would determine the cost, whatever that function is. On the other hand, consider the function that determines the number of sandwiches you bought based on the cost. So what I want you to really focus on in these two functions is the input and the output. What do you notice about the input and output of those two functions? Yeah, they're switched or they're opposite. This is what we call inverses because their inputs and outputs have exchanged places. Okay. Any function that has an inverse we say is invertible. And the way that we denote an inverse is with this symbol. That is not an exponent. You probably saw that in algebra too. But this indicates the inverse of function f. Okay, that's not f to the negative 1. That's the inverse of function f. Do you remember seeing that last year? No? Okay. Okay, so the first thing that we are going to look at is how to find the inverse of a function algebraically. So we have y equals f of x equals 2x plus 3. This is essentially y equals 2x plus 3. What we are going to do is switch our x and our y because remember, inverses, we are switching the input and the output. So we are literally going to switch the x and the y, which is the input and our output. And then we are going to solve for y. So we switched x and y. Now we are going to solve for y. So to solve for y, I would start off by subtracting 3 from both sides. And then I would divide everything by 2. We need to make sure that we are indicating that this function is the inverse. So all I'm going to do at the very end is change that y to the inverse of f of x. That shows that this function is the inverse of our original function f of x. I want you guys to take a couple of minutes to try example B. So similar type of thing. Switch your x and your y, solve for y, and then just watch your notation at the end. All right, Allie, what did you do first to find this inverse?
I changed, well, I put y equals 2 thirds x plus 30.
Okay.
And then I just changed the y and x, so it equals x equals 2 thirds y plus 30.
Okay.
And then I subtracted 30 from both sides, so I had x minus 30 equals 2 thirds y.
Okay.
And then I basically just multiplied 2 thirds on both sides.
You multiplied what on both sides?
2 thirds. Oh, I multiplied 3, don't I, first?
Yeah, we need to multiply by the reciprocal, so we need to multiply everything by 3 halves instead. So what would that give us, Allie? Okay.
Oh, 3 thirds 32x minus 45.
Minus 45. Okay. And then at the very end, we do what?
Change y to, I don't know how to say it out loud.
The inverse of g of x. Can I answer any questions there? You would have seen this in Algebra 2. Kinsey?
I don't get on the first one how we like switch the fraction. Like for our answer.
Switch
Oh,
what?
wait, just kidding. I just made something up in my head. Never mind.
Are you sure?
Yeah, I don't know why.
Okay. Any other questions before we look at it a different way? Okay. So that's finding inverses from the equation. So now let's look at thinking about finding the inverse from a graph. What I need you to keep in mind is that the inverse of a function switches your domain and range, your x and y values, okay? So this will kind of get us thinking in that direction. So from the graph, what is f of 0? We're just evaluating plain old f of 0. 5. Okay? So let's think about what this is asking you to do. F of 0 is asking you to find the output when the input is 0, right? Okay, what's the output when the input is 0? That's 5. Okay, now what is the next one asking you to find? Okay, find the input when the output is 0. So now I'm looking, when my y values are 0, what are my x values? I have 1 at -2, and it does actually hit 0 at -10. So I have 2 input values that would make an output of 0. Here's where it gets a little bit fun. So this wants the inverse of 0. So how is this going to be different than finding f of 0? What do you think, Allie?
Oh gosh, one like since it's the inverse, basically would be asking like what would the output be almost and kind of go right before it. Like, 'cause the output
Yes. Yes. Like the one right before it. So because the inverse is switched, you can kind of think about this as what's the input when the output is 0. Yes, you're right. because your domain and range is flipped. Your domain and range is flipped. So this is essentially asking for your function, what's the input when the output is 0? So the answer would be
Essentially what you
what we did on the one before. I put those there so you can kind of get that connection, that we're literally flipping the domain and range, the input and the output. So what about this one? Inverse of what equals 0? So what is this really saying for the function? Amber?
basically saying, what's your output when your input is 0?
Exactly. What's the output when the input is 0? And what is that?
5.
5. So these two are kind of saying the same thing. So these two are kind of saying the same thing, and then the first and the fourth are kind of saying the same thing. Katine, the next one. What is, now just pay attention, it's just the function of -6. -4. Okay, so this is just saying what's the output when the input is -6. The last one, now I'm looking for the inverse of what equals -6. Anna Marie, what is this one saying?
It's -4.
Okay, but what is it saying? Or what is it asking?
The inverse of y value.
Can you say that in a different way?
Just looking at the x value.
This is really asking us, since it's the inverse, this is really asking us not to find the input, but to find the output. Okay? It is -4. These two things are essentially saying the same thing. Okay? Can I answer any questions? All right, then I'll move on. Similar type of thing. This time we have a chart, or excuse me, a table instead of a graph, but similar type of thing. So now I want f of 0. Samantha, what is f of 0?
2.
2, good. Gabby, what about the inverse of 0? What is that asking us to do?
It's like opposite of 4.
Okay.
So
It is 1. Okay. So it's almost like saying when the output is 0, what's the input? You got it. Jack, what's f of -2? Okay. The next one is the inverse of -2. Alyssa?
So wouldn't that be when you plug into
Yes, exactly.
well, isn't it?
You're right. I kind of had a trick question. That's not defined in our table, so we don't know what that is. Eric, what's the inverse of -3? 2. Sarah, the inverse of what equals -3? It is not. So this is kind of saying f of -3 equals what? This correlates to f of -3 equals what? Say that one.
Is it not?
Yeah, it's not defined. It's not defined in our table, so we don't know. So then I'm looking for the inverse of what equals 3. Jason? That one is defined. It is.
Oh,
It's
it's negative 4.
-4. There you go. This really gets your head thinking like crazy things. Can I answer any questions? Please ask. Okay, then I'll keep going. So in the next few examples, we have real life-ish situations or contexts. We want to think about what the inverse would be and then give the meaning of the inverse. So for the first example, it says P equals F of T is population in millions in year T. So that would mean that if we plug in the year, it would give us the population in millions. So first of all, the inverse would be T equals F of P. We're just changing the input and the output. So what is the meaning of that? Alyssa?
Plug in the population and we'll give you the year.
Yeah. So the inverse gives, let's talk about it in terms of what the inverse will give you. The inverse gives, what, Alyssa?
The inverse gives the year based on the population.
Yeah, it will give the year T based on or for a population P. Good. Okay, let's think about the inverse for the second one. So I'm literally just flipping my input and my output. So T now equals F of N. Jessica, what is the meaning of that inverse function?
The day of January depends on the inches of snow.
Say that a little bit louder.
How many inches of snow will be on each day, like depending on the day.
Okay, that's the function. The number of inches of snow.
Depending on the inches.
I'm sorry, what?
Depending on, I don't know, I guess I'm confused.
So the original function gives the number of inches of snow based on the day. So what would the inverse give? Try it again, Jessica.
The day based on how many inches of snow.
Yeah. The inverse will give the day in January for a certain number of inches of snow. And then finally, if we think about the inverse of the last one, T equals F of V. Mike, what is the meaning of this inverse?
The inverse gives the time after starting to assist.
The inverse gives the time after, okay, yeah, after starting, finish your statement again.
To a certain speed.
For, yeah, okay, good. For a certain speed or velocity. Good. Okay. You'll have several problems in your homework where you're doing a very similar thing. You have to kind of think about the inverse and then interpret if this is what the function gives, what would the inverse give? Okay. All right, we have just enough time to look at the very last example, talking about domain and range of an inverse. Remember that your input values of the inverse are the output values of the function and vice versa. So the domain of the inverse is essentially the range of your original function. So we have f of x equals the square root of x minus 4. So let's first think about the domain and range of our original function. Hopefully we're doing a little bit better with this. So if I'm looking at that square root function, I'm thinking what in terms of my domain? It can't be negative, so I'm thinking that my domain has to be greater than or equal to 4. And what is the range of that function? Very good. So if then I'm thinking about the domain and range of the inverse, remember the domain of your original turns into the range of your inverse. So the range of the inverse is that y is greater than or equal to 4. And the range of our original function becomes the domain of the inverse.